So again, 12E, our objective of the day is to solve these formulas for a specified variable. We are going to be solving most of these, all of them, for the variable y. That is such an important skill for us to be able to do. If you look at your calculator right now, at the top left-hand button, it's a gray button. What does that gray button say? Oh, on the other side, the left side. Y equals. There is a whole button on this calculator, and same is true for Desmos. I mean, it's not a button, but this still rings true. You have to have your equation set equal to y, or solved for y, so that we can graph them in the calculator and in Desmos. So this skill is going to be super important for us to be able to do that in our next unit. Okay? Now these literal equations, that's what this is called, a literal equation, as opposed to a single variable equation, are equations that contain two or more variables. In this case, our equations are probably going to include the variables x and the variable y at the same time. So you know how up to today you've had x's, or you've had y's, or you've had t's, or you've had r's, all the different letters, but they're always the same. On the quiz you just took, there was one with n's. They're always the same, but in literal equations, there's going to be more than one type in a single equation. Please notice, down here you have negative y equal to negative 5y equal to 15 minus 3x. We have x's and you have y's. Y minus 3 equal to 2 times x minus 6, x's and y's. 3x plus, I can read, wow. 6x plus 3y equal to 12, x's and y's. 1.2x plus 3.9y equal to 17.6, x's and y's. So you see what's happening here? This is different than what we've been doing. But this being able to rearrange or solve an equation for a particular formula, rearranging formulas by solving them for a certain variable, can simplify calculations, especially if you go into physics or you're looking at engineering as a career. This is huge. Or graphing them using technology, which is what will be helpful in our class. Okay, we're going to do an example comparing what we have been doing with what we're doing now. For this example, though, I'm not going to use the box method. I'm going to go back to what we did our very first day we took notes and use inverse operations, just so I can show you how this has changed. If you notice, this first box says solve 5x plus 10 equal to 30. Okay, that's my regular equation. How many types of variables does this equation have? This one only has one type. They're just x's. That's a regular called single variable equation. If we were going to solve this, we're going to do reverse Pemdas, inverse operations. How do I get that positive 10 to the other side? What's its inverse? Minus 10, yeah, negative 10. So I do that, and I would get 5x equal to 20, right? Why were we able to actually do this right here? I subtracted 10 from 30. I'm able to do that. Why?
You have to cancel out the 10.
I do have to cancel out the 10 because this part right here needs to go away, absolutely. And when I put it onto this other side, though, why am I able to subtract 10 from 30? Things that we can add or subtract together have to be like terms. Are those like terms? Yeah, okay, cool. We've never questioned this before, but it's going to come into play. This is why I'm asking this question. To keep going, to solve 5x equal to 20, 5x means I'm multiplying. What's the inverse of multiplying? Dividing. So I'm going to divide both sides by 5. I'd be left with x equal to whatever 20 divided by 5 is, which is 4. I have my solution. That's the goal of solving a single variable equation. But if you notice, the other side of this, it says solve 5x plus 10y equal to 30 for y. So let's write this equation down. 5x plus 10y equal to 30. We want to solve it for which variable? Y. Okay. Reverse Pemdas still exists, okay? So if I want to take the term 5x and I want to move it to the other side, just like we did that 10, what would I do? It's currently positive, so I would do minus. Yeah, so I'm going to minus 5x. The whole thing moves over. But look at this particularly right here. I'm going to do minus 5x. Why do you think I moved it to the side there? Why did I not just put it right underneath 30? They're not like terms. This has a variable. Does that one? No, we can't combine them if they don't have like terms. So what we would do is we'd cross this one out. We'd bring everything down like we just did. 10y equal 2. And then you just write both things down. You're going to have negative 5x and you're going to have a positive 30. Now, I did reverse their order, and I did that on purpose. You'll kind of see when I get to my final answer here why I did that. But you do want to write the x term first and then the constant behind it.
So, what you do is...
Okay, if we kept going, though, what did we do on this step on the solving for x, the purple step?
I don't know.
What did we do? Well, you can look at it. We divided. Why did we choose the number 5?
Because this is the variable.
It's in front of the variable, right? So what number are we going to choose over here? 10. Now, here's the thing. You do divided by 10, you do divided by 10, and you do divided by 10. Every single piece of that equation has to be divided by 10. You're dividing everything by 10. This term and this term. This is new.
Where did that come from?
What do you mean? So once we've divided by 10, this would cancel out. You'd have y by itself, which is what we want. We want y by itself. In your calculator, in your brain, what is negative 5 divided by 10 given to me as a fraction? Negative 1 over 2. Thanks, you have a calculator for that unless your brain knows that. Then I'm going to put the x next to it. What's 30 divided by 10? 3. That's when I'm done.
Oh, so where did the 30 come from?
Where did the 30 come from? It was in the original equation. Here's my thing for you. This is why I rewrote it in this manner. Do y'all recognize something about that y equals equation?
Yeah.
Maybe something that looks like this?
Yeah. Fuzzy.
Oh, snap. We know this equation. That's the line. We're writing lines. So we're taking equations. This is called standard form, which we'll get to later. You don't need to know that yet. And we're rewriting it for this form. Does anyone remember the name of this red form of the equation? Slope.
Slope y-intercept.
Slope y-intercept. Slope-intercept form. That's exactly what we're doing. Guys, we know this stuff. It's just a new process to get there.
The equation form is like...
That's the process. It is truly 2 steps. Move the x term, divide by the coefficient. That's it. We'll do a bunch of practice problems to make this make more sense, because right now you've never seen 2 variables at the same time unless you're just graphing it. So I know it feels a little wonky in our brains. Let's go to the back of this and try a bunch of practice problems together.
The back?
Uh-huh. It's your notes. Here we go. Example 1 says solve for y. That means we are trying to get the y by itself. I want everyone right now to circle or star or highlight the y. We're trying to get it to where that is the only thing on the left side of the equation. Reverse Pemdas. If I'm going to take that 4x and move it to the other side of the equal sign, what do I have to do to it? Drop it down by subtracting, right?
Yes.
Now, I remember, I'm going to write that minus 4x not underneath the 20 because it's not a like term with the 20. So I can't combine it. Then I have y equal to negative 4x plus 20. Is the y by itself?
Yes.
Okay, we're done.
That's it?
Yeah, I asked you to get the y by itself. Didn't we do it?
Yeah.
Great. And that's y equals mx plus b.
Maybe I'll first.
Okay, you guys try example 2. It's underneath. Underneath it is example 2. You guys try that one. Okay, let's see how we did. I'm seeing some people finish. So we should have drawn a line down our equal sign because that still exists. Left side, right side. We are trying to get that y by itself. If it helps you to circle it, circle it. Now, reverse Pemdas rules to move that 7x, which means what am I going to do to both sides? Add 7x. Not just 7, 7x. But I'm not going to combine 12 and 7 because they're not like terms. So that means I'm going to have y equal to
7 plus 12.
7x plus 12. If you wrote y equals 12 plus 7x. That is still the same thing. I just would prefer the x term going first. Is that okay? Okay, so there's the first step. This was a simple equation because we just had to do one of the steps. Move the x term using inverse operation.
Wait,
No big deal. Let's look at the third one.
oh, it still counts when you move it across, and so like it changes what.
Cross the line, change the sign, right? Yeah. There's an x and a y. So again, circle or highlight or star or underline the y. We're trying to solve for y here. I need to do the inverse of 2x. What is the inverse of 2x? It's positive, so what's the opposite or inverse? Oh, sorry, I didn't hear you. Negative 2x. So I'm going to do that on both sides. But don't line them up because you're going to trick yourself into accidentally combining like terms. Bring down everything. What am I bringing down over here this time on the left side? 3y. 3y equal to negative 2x plus 12. So right now we've moved the 2x. Does everyone agree with that step? Yes. Is the y by itself?
No.
No. What's next to it right now? How do we get rid of that 3? Divide. And do I just divide the first things?
All of them.
All of them get divided by 3. It's 3 little division problems. The first one's easy. They just cross out. We'd be left with y equal to whatever negative 2/3 is, but give it to me as a fraction, please. Yeah, negative 2/3 x. And then whatever 12 divided by 3 is, which is? 4. I'm done.
Oh, I get it now.
It's just 2 steps. Inverse operation, or moving it, and dividing. Like actually do the division. Can you guys try example 4? I just said example 4. Look how many fingers are up. That's embarrassing. I'm holding up 2 fingers. Try example 4, please. That one's yours. We should have, on this one, drawn our line. So yes, minus 4, minus 4x, minus 4x. Now remember, what variable are we solving this for?
Y.
Okay, make sure you know what you're solving it for every time. This would become 9y equal to negative 4x plus 36. Yes? What am I dividing by? 9. And I'm dividing it everywhere. So I'm going to divide all of that together. I should get y equal to negative 4/9 x plus 4.
Yeah, I get it now.
Yeah? Are we feeling good?
Yeah.
Can I show you the kind of problem students make the most mistakes on, though?
Yeah.
It's numbers 5 and 6. And it's silly mistakes, okay? It's a silly mistake. Let's look at number 5.
They look the same.
You're right. They look the same. So on number 5, together, we would draw our line down the center of an equal sign. What's the inverse for the x? Because remember, we're solving for a y. So what am I going to do?
Plus 2.
Plus 2. Just 2?
X.
X, thank you.
I said first. No, I did.
No, I didn't.
And then we would keep going. So the 2 x's cancel out. They're a 0 pair. I'd be left with negative 4y equal to 2x plus 12. So I've already passed through the step where most students make a mistake on this problem. What mistake do you think that they make?
The inverse.
I'm
dropping down the 2x and being a negative.
Keep thinking, where else could I have made a mistake on this? Are you talking about this one right here? This is what I'm talking about.
Say yes.
Say yes. On all the problems we've done so far, you've just dropped down the number, right?
Yeah.
This is a negative 4. Do you know how many times students will just write down 4? Oh my gosh, this is a negative 4. Don't lose this negative. Make sure when you're moving the 2x over that you don't think this is 4y. This is negative 4y. Big difference. So make sure you're using the correct number here, including its sign. But let's keep going. Wait, sorry, I heard a question. What would I divide all of these things by? Negative 4. So make sure you actually divide by that negative number. Negative 4 over negative 4 cancels out. You'd have y equal to whatever 2 over negative 4 is, which is negative 1/2 x. And then whatever 12 divided by negative 4 is, negative 3.
Wait, the x still counts?
What do you mean? Oh yeah, the x is a part of my answer. If you start with 2 variables, You better end with 2 variables.
I need that.
Don't let it become 1 variable. You had 2 when you started. Can't lose them. Does that make sense?
Yeah.
Okay, 6 is yours. Don't fall for the trick. It's there again. I guess I shouldn't have warned you. Go ahead and try number 6. Okay, I'm seeing enough people finish, so let's go over it together. We should have drawn our line. Okay, come on, guys. Gotta keep up the pace. We're gonna draw our line. We're gonna subtract 5x from both sides because that's its inverse. We don't combine those like terms because they're not. Because remember, we're just trying to get this y by itself. What should I write down next? Negative 3y, good, equal to negative 5x plus 15. Y'all didn't let it float away. I'm very happy. What are we dividing by here? Negative 3 everywhere. We should get y equal to 5/3 x minus 15/3. Uh-huh. Oh, shoot, you can reduce that, can't you? 15 divided by 3 is 5. Y'all are right. Thanks for catching my mistake. How do we feel? Good. Couple of moments to remember. Don't drop my negatives. Don't combine unlike terms. They don't go together. If you start with 2 variables, you have to end with 2 variables. If you start with 3 terms that are all different, x's, y's, and numbers, you have to end with x's, y's, and numbers. Don't start combining stuff that don't go together. Yes. A nice little segue into number 7 was this question. If you look at number 7, does this one look exactly like the other ones did? No, but what does the instruction still say?
Solve for y.
Solve for y. We're still going to try to get that y by itself. But what do you notice that's happening on that right side? You just talked about it.
You're solving it? No. Wait. You're multiplying.
Distribution, the multiplying. Okay, we know how to do that. Anytime there's a number in front of parentheses, we can distribute. I didn't change anything on this side, so I'm just going to rewrite down y minus 5. Then I'm going to have 3x and positive 6. Have I lost anyone? No, distribution, right? We've been doing that for a while. But remember, we're just trying to get that y by itself. What's on the same side of this equation as y?
Negative 5.
Negative 5. What's the reverse PEMDAS of that?
Adding.
Positive 5. Now I have a question for you. Should I put plus 5 underneath the 3x, or should I put plus 5 underneath the 6?
The 6.
Why the 6?
No variable.
It doesn't have a variable. Those are both constants, so I actually can combine like terms here. What's 6 plus 5? 11. So here we go. Y equals 3x plus 11. I'm done.
You are?
Yeah. Isn't it solved for y? Is the y by itself?
Yeah.
It's all the way by itself on that left side. We're good. That's what it's asking for. Yes, sir. Yeah, group passes over there by the door. Can I leave you to try these 3 problems?
No.
All 3 of them. I want to see what you can do with all 3 of them. Please notice on number 9, what number is in front of that parentheses?
Negative 1.
A negative 1. Okay, cool. Y'all go. You got this.
Slide 50.